Good morning, guys. This is Mr. Holmes getting ready to talk to you guys about slopes of lines as well as determining if they are parallel or perpendicular. All right. So this morning we're going to be talking about parallel lines. And then we're going to be talking about perpendicular lines. All right, in parallel lines and perpendicular lines, there were some things that we had noted already, and I'd like to bring those to your attention. The first thing I want you guys to remember is that parallel lines have the same slope. The slopes are exactly the same. Whereas with perpendicular lines, their slopes are negative reciprocal slopes. And just to give you a quick heads up, is here you have two slopes. One of the slopes, and let me push this one a little over here. One slope would be like 3/4 and 3/4. Whereas in perpendicular slopes, one slope would be 3/4. The other slope would be negative 4/3. That's what we mean when we say negative reciprocal slopes. Negative meaning one going to be positive, one of them will be negative. Reciprocal means they will be flipped. One of them is 3/4, one of them is 4/3. Another example would be m is equal to, say for instance, 1/7. Let's call it negative 1/7. And the other slope would be a positive 7. You see how I went from a fraction to an integer? Because the slope is understood to be 1 here already. Sometimes, to determine if lines are parallel, you can simply look at the slopes when it's already written in slope-intercept form. Something like 2x plus 7 and y is equal to 2x minus 3. My integers are the y-intercepts. They does not determine whether lines are parallel. They have nothing to do with parallel or perpendicular lines. However, it's all about the slope. The slope is the integer, that number that's in front of x, that's in front of your variable. That's the only thing we are to look at to determine if they are parallel or perpendicular. In this case, since the slopes are exactly the same, they are parallel. Sometimes, and I'm going to erase this, sometimes you have to determine the equation of the line by actually solving for y. I'm going to write the exact same equation that I just had here. Only difference is I'll put this one here in standard form. Sometimes you would have to solve it for y. In solving for y, you have to get y by itself. In doing that, you will always just do the opposite operation. So in this case, to get rid of my 2x to put it on this side, I would do the opposite of a negative 2x. I would simply add 2x to both sides. That would make this go to 0, leaving me with y is equal to a positive 2x. And remember, we always want the slope first, written in standard form. This is the standard form for slope-intercept. And we want the y-intercept last. And sometimes you have to solve it for y to determine if lines are parallel or perpendicular. So here's another example. Here, y is equal to, let's write them both in standard form here. So y, let's make it an x. 3x minus 4y is equal to 12, and a 4x minus, let's go plus 3y is equal to 15. To determine if these lines are parallel or perpendicular, I will simply solve both of these equations for y. So here is what I'm going to do. I'm going to write this equation further to the left, write this equation further to the right, and we're going to solve and look at their slopes. Okay? So here I'm going to write 3x minus, I'm going to put the 4y equals 12. 4y is equal to 12. And on this side, I'm going to write my 4x plus 3y is equal to 15. Here, I want to see, are these lines parallel, perpendicular, or neither? So in order to do this, I need to solve it for y. I'm going to do the opposite of a positive 3x. I'm going to subtract 3x from both sides. In doing so, it'll leave me with a negative 4y is equal to a negative 3x with a positive 12. And the last thing here is I will divide each one of these by the coefficient of y. In this case, it's negative 4. Remember, you must divide all of them by whatever the coefficient is. In that case, my force will divide evenly one time, leaving me with y equals. That lets me know I'm doing it correctly, and I'm about to write it in slope-intercept form. Remember, when you divide a negative by a negative, the answer is always positive. So this one here is 3 over 4x. When I divide a positive 12 by a negative 4, I'm going to get a negative 3. So this was written in standard form. Here is written now in slope-intercept form. And I want to do the same thing on this side to see if these two lines will be parallel, perpendicular, or neither. So to solve this for y, I would have to subtract 4x because this is a positive 4x. So I'm going to subtract 4x from both sides of my equal sign. In doing so, it will leave me with a 3y is equal to a negative 4x with a positive 15. So I'm going to put plus 15. And then the last thing I'm going to do here is I'm going to divide each one of these by the coefficient of y. In this case, my coefficient is 3. So I'm going to divide by 3. Whatever number is in front of y, that's the number you divide by. In doing so, the 3 divides 3 one time, leaving me with 1y. If we don't put the 1, it's understood to be there. And I'm going to get a negative 4 over 3x. And 15 divided by 3 is simply 5. Now remember, we did this because we wanted to see if the lines were parallel, perpendicular, or neither. So I'm going to look at simply the slope, only the slope. Here are my two slopes. I have one slope as 3 over 4, one slope as 4 over 3. So clearly they are reciprocals. The question is, are they negatives? Meaning, is one positive and one negative? Clearly this one is positive, clearly this one is negative. Since these two slopes are negative reciprocals, I would say that these two are perpendicular. So here I'm going to write the word perpendicular. Perpendicular lines. And the symbol for perpendicular, and I'm going to put it in parentheses, it looks like a T, but it's upside down and it does not connect. All right, that's the symbol for perpendicular. Make sure that you jot this information down. If you have questions, please write those burning questions down and come see Mr. Holmes. Other than that, guys, have a very blessed day.